Hope Leonard is a Brevard native, and she's currently the Conservation and Restoration Coordinator for the Restore Our Shores team at the Brevard Zoo. And today she will be talking about IRL bivalve restoration and evolution.
Hello, that was a great intro. But yes, my name is Hope. Pretty informal, so always just Hope's fine. But yeah, so I am part of Brevard Zoo. And so a lot of people is it on? And so again, mission at the zoo is to we share our joy of nature to help wildlife and people thrive. And so a lot of people always ask, well, why is the zoo interacting with stuff in nature and out here in our backyard? And we find that that is the best way to fulfill our mission, is to go out into the community and the people that support us and to actually find a way to help the people of this local community thrive with nature. And so by doing that, we created the Restore Our Shores program, which is what I am actively a part of. Yeah, it's fine. So Restore Our Shores has been going now for about 10 years under this name officially, but we have been restoring oyster reef in the Indian River Lagoon since about 2008. We were actually up helping UCF restore Mosquito Lagoon oyster reef before the sorrel program started. So we can get into that a little bit. Just, I think I got it. Yeah. And so let's just talk a little bit about Brevard, early Brevard. So Brevard in 1984, let's take a look at this yellow line that's kind of going across the screen here. So for those of you on Zoom, the yellow line is going across the screen. And so this is 1984. 2022. So let's go back and forth. Do we see all of this impermeable surface that has appeared? So that's mostly Vieira area, things like that. So we talk about pollution here in Brevard County and pollution in the lagoon. And we wonder, okay, well, what's happened? So we've had a huge population growth. We've also had this increase in concrete surfaces. So we have less plant life and less areas for water to essentially naturally flow off of our yards, off our surfaces, off concrete, and slowly sink into the sediment. It goes into the waterways now. It goes funneled through our drainage systems and into the lagoon. So part of that program that we're going to talk about in a minute that funds a lot of Restore Our Shores work and Indian River Lagoon restoration, the sorrel program by Brevard County. We're going to talk a little bit about that because this is the main reason why we've had these issues with seagrass, with pollution in the lagoon over the last few years. There we go. And so let's talk a little bit about sorrel. So here in Brevard County, we are one of the only counties in the state of Florida that have actually passed a sales tax that actually helps to restore the Indian River Lagoon. And so that half-cent sales tax goes towards the 4 R's. So the first R is reducing nutrients, which is nitrogen and phosphorus, removing muck, restoring natural filtration systems, which is oyster reef, living shorelines, which MRC knows a lot about. And then respond, so the living document. So this program is always changing. There is a citizens oversight committee that actually goes over and votes on where this funding goes, and monitoring. So with that, we are part of the Restore Natural Filtration Systems within this program, which happens to be oyster reef. And then it has been expanded upon to clams, as well as some seagrass projects. And so today we're going to talk a little bit more about the evolution of the Restore Our Shores program and the evolution of oyster reef restoration and clam restoration here in Brevard County. And so the evolution of our program, so in 2009, oyster mats, Mosquito Lagoon. So a lot of you who have been here a long time may remember oyster mats. Intertidal oyster reef requires oyster mats. And so that's what we were doing in 2009. And we were doing such a good job helping UCF that in 2014, when Brevard County started thinking about this sorrel program and passing this tax and wanting to do restoration here in Brevard, they were like, well, why don't you guys come up and help us restore oyster reef in your own backyard? You're already going all the way up to Mosquito Lagoon. Why don't you help us here? And so that's when we started the oyster gardening project, so where we grow oysters with volunteers off the dock. Some of you may know about that program. And then in 2016, Save Our Indian River Lagoon was officially passed. So that is where the 4 Rs come in. And that's where we started really building our oyster reef restoration. And then 2023, Brevard County expanding the community collaborative. So it went from not just oysters into bivalves, more bivalves. So another bivalve, bi means two, valve, and so another bivalve is clams. And then also seagrass. And so some of our programs, other than what I'm going to talk about today, Shuck and Share, oyster gardening, reef restoration, spat monitoring, those are all about oyster reef. So Shuck and Share, I'll talk about in a second. Oyster gardening, where volunteers can raise live oysters off their dock. Reef restoration, I'm going to talk about that today. Spat monitoring, that's monitoring the oyster larvae within the water column here in Brevard County. So monitoring where oysters are spawning and going. And then other programs, adopt a mangrove, living shorelines, buffer zones, bird island monitoring. And if you have any questions about any of these other programs I'm not really going to speak about today, you can always come talk to me. Then clam restoration, clam gardening, and then seagrass restoration and water quality sensor monitoring. Mouthful. And so let's talk a little bit why we put so much effort into oyster restoration itself here in Brevard County. I think that works. So many of you may have seen this time lapse before, but it's always a very great thing to start with when we're thinking about oyster restoration. And
oysters that we grow in here at the MPL. I talked about these little aquatic engineers and how efficient they are at filtering the water. And so this is some algae that we grew here at the MPL, but these are naturally available. Yeah, that's a good meal for these guys. And I calculate that in this 5-gallon aquarium with this many oysters in here, that the oysters should be able to filter the algae out of the water and make it virtually clear in the course of about 2 to 3, maybe 4 hours to most.
What was that? How many hours?
2 to 4.
2 to 4. So you can kind of see the puffs coming out of the oysters. That's them expelling the water that they've pulled in to eat that algae and push out. So when we talk about natural filtration, this is what we are talking about. We have a nutrient issue problem from the runoff, from the overpopulation of this area and the impermeable surfaces that we've continued to add to this area. And from those nutrients, algae. Oysters eat algae, and they also provide amazing habitat. So why oysters? Natural filtration, amazing habitat. I believe in this clicker. It will work. Okay. And so when we talk about oysters, so oysters are gregarious. So when I say the word gregarious, it means they like to grow in groups. They actually will cement onto each other and grow on top of their parents, kind of like corals. So the first layer is what's normally alive, and then there'll be some down below that are alive, but they'll continuously grow on top of each other. And so that habitat and that structure creates amazing habitat, as well as having this amazing filtration. There we go. Shoreline stabilization. So when you have this mound of shell that is concreted together in front of a shoreline, it is a breakwater, a natural breakwater that will break before it starts eroding your shoreline. So shoreline stabilization, and then nutrient removal. So that nutrient removal, oysters filter algae out of the water, and through that filtration system, they actually digest those nutrients, and through their pseudofeces, they can actually create nutrients that are bioavailable to bacteria that can convert them into that go from inorganic nitrogen to bubbled out nitrogen gas, which completes the nitrogen cycle, which might be a throwback all the way to like high school, really, really far back, but even for me. But that is the purpose of oysters in their environment is that natural filtration process and removing nutrients from the water column directly and helping to bury them into the sediment. And so here, when I talk about subtidal versus intertidal oysters, we have really one main species of oysters here in Brevard County that are prevalent, that have been prevalent for hundreds of years. And we know that through the shell middens here in Brevard County. So those piles of shells from the Native Americans that used to live here. And here in Brevard County, many of you may have noticed, we don't have much of a tide. So our oyster reefs are subtidal. So we're not the only ones that have subtidal oyster reefs, but they're the same species of oyster, Crassostraea virginica, that also exist in St. Augustine, in Tybee Island, in Georgia, all the way up the east coast of Virginia. And so same species, but they adapt to be here just as they adapt to be there. So with our species and with our gardening programs, if you ever heard, we still leave those oysters out. They can be out of the water for hours at a time because they are the same species, but the ones that we put in the river and the ones that grow naturally here, for the most part, are under the water at all times. And so when I talk about a gregaria species like oysters, what do you think the best form of restoration material would be if we wanted to create a faux oyster reef? Oyster shell, oyster culch. That word culch is very prevalent in this restoration industry. And how do we get this oyster culch? We have a shuck and share program. So we recycle all of our oyster shell here from Brevard County. So through this program, we will take oyster shell from restaurants, let it sit out for at least 3 months. So we let that sit out, we cure it, you know, the nice fancy word for, we let it sit in the sun and let everything die off of it to make sure that there's no invasive species being introduced, nothing like that. And we put that shell into our oyster restoration programs. So since 2015, we've had those oyster restoration programs going, and we've had amazing success, especially with our oyster gardening program. We've trained over 1,600 oyster gardeners. We have a little bit more, it might be 1,700 now after this past season. But last season's oyster gardeners actually produced over 140,000 oysters for our oyster restoration projects here in Brevard County. So amazing work. And all of this goes into, all these live oysters are seeded onto our oyster restoration projects, so our big oyster reef projects, in areas where we have found that there are less larvae in the water column. So in areas where our spat monitoring or oyster larvae monitoring has been lower compared to other areas. A lot of research, a lot of monitoring makes all this come together. So oyster reefs. So we've built over 74 oyster reefs since 2014. That's actually an old number. We actually reached 100 this year. And just in the past few months, we reached 100 oyster reefs. So we've built over 2 miles of reef covering over 2 acres. And we've tested new methodologies because you start with a product, you start restoring, and things evolve. And so that's what I'm going to talk to you a little bit more about today, is the evolution of oyster restoration and clam restoration here in Brevard County. And so you can see some of our later projects here. And so first, the pilot projects and bag projects. So bag projects, they were using a aquaculture grade mesh, and we would fill that mesh with oyster shell, and we would stack it like this and attach it to each other and build these long oyster reefs with the shell inside. And this is kind of how you would see the oysters growing. You'd see some oysters growing inside, but for the most part, they'd start growing on the outside. And so we saw a lot of sedimentation with this because there's not a lot of, those openings are so small. So sediment would get in and sediment would not get out of those bags. And then in high energy areas, so areas where there's a lot of wind energy that can build up over the water. So what we like to call fetch. So when there's a long distance of between shorelines, that's a lot of area where a wind can pick up that wave and hit the reef. And so we saw some material loss. So some of that bag mesh was breaking apart at these sites. And then permitting limitations because it was plastic. It was aquaculture grade mesh, which is plastic. And so as we kind of got into this. We have in the last 4 years gotten away from this because we wanted to move away from plastic. We didn't want to use it anymore. It wasn't effective in all areas. It was effective in some, but it wasn't effective in all. And so that wasn't our best method. And so we evolved, just like the best things do. And so you can kind of see what this looked like. So the next evolution was we started using Gabion metal. And so metal that is galvanized steel that we would form into these boxes, and we would stack them like this to create a very similar structure. And what we saw was incredible with the change from bags to Gabions. And so another evolutionary step, once we got there, Gabions, as you could maybe imagine, the metal is expensive. Per square foot, it was costing us a lot of money. And we weren't getting any more money for the projects than we were when using the plastic material. We were just essentially trying to evolve in a way that made the projects better themselves. And so we needed a way to actually make this feasible for the amount of money we were being reimbursed. And so what we came up with was Gabion corrals. And so we actually built this fence along, which is just a regular Gabion, similar to the bags and the shell. It was just filled with shell. And then inside was shell culch. And so it was just a bunch of shell, just like a natural oyster reef would be. But according to permitting agencies, we have to have a fence. It's got to be contained. And so we used the Gabions filled with shell to actually contain this material. And we made them a bit taller so that we wouldn't have to stack them, which made them a bit more secure. And so next evolution, final evolution, which is what we do now, is no man-made material at all. So this is the most recent thing that we do, which is coquina corral. So we actually have built a few of these projects. The one that just got monitored yesterday is offshore at Turkey Creek. So we have some very large projects with coquina corral around, shell culch in the middle. And the project yesterday was looking like it was going to have about 1,000 oysters per square meter, which is insane. Very high, so very excited. So we'll see how those continue to do, but let's go over why we made these decisions as we went through. You've seen all the evolution and heard our side of why we did it, but was there any science to back us moving along with this? Sorry, I'm trying. And so we monitor our oyster reefs. You have to. For the Brevard County Sorrel Project, we actually have a third-party monitoring system where UCF actually comes in and monitors our reefs to keep it honest. Not that we would ever lie about our numbers, but keep us honest because we are using taxpayer dollars. So got to be honest, got to use a third party. And so I have some numbers for you guys from UCF. So this is shell bags versus Gabions. This is monitoring dates. And this is number of live oysters per liter of shell. And so, as you see here, the Gabions are the orange line and the shell bags are the blue line. The shell bags always had a lower amount. So we had a very clear message to move on from the bags into our shell Gabion. Density in the corrals by volume of shell and surface area. So for oysters, we can move on from the expensive only Gabion building material to our corral structures where we have that fence of Gabions with the shell in the middle. There we go. And then from that, we are currently monitoring the offshore projects that are coquina corral and Gabion projects, and we're looking towards moving towards just doing the coquina. But all the preliminary data that UCF has given to us has showed that the corrals perform just as well as the Gabion corrals because there's really not much difference. So that's exciting. And I'm going to talk a little bit about our oyster spat monitoring. So how do we know where to put these reefs? It's not just you put anything out there, it does well. We do have a segmented river. So we built causeways, not breezeways. So we have these land bridges that go out. They do restrict flow in the river. So we actually track spat through our oyster gabion here. So that's sitting high enough off of the bottom to where we can attract larvae. And so we are actually expanding this program. We'll be doing about 15 sites. We have some federal funding that we have to expand this program, which is very exciting. And so we'll be adding 7 sites to make 15 sites in Brevard County. And then we'll have continuous water quality sensors at 4 of those sites. And so this is just to, again, improve that oyster reef building area. So we're deciding, okay, we can't just put oyster reefs anywhere. We have to put them in places where they are going to be successful. And so this is a major part of what makes our oyster reef successful, because we need to know that there's larvae in the water column in order to have a successful project. And then part of this is also, we are also collecting live oysters from 4 of those locations with the water quality sensors. And we're actually going to be looking at oyster reproduction health. And that's a new portion. So we're trying to do all we can to make sure that our projects succeed and to see how we can actually improve oyster quality here in Brevard County. So what we've seen in the last few years through this evolutionary process, we've seen where oyster reef can be built, where it has limitations, and where those limitations have slowly improved through the years. Because when you're just putting projects out, some projects didn't do as well in those first few years because we did not do the spat monitoring. We didn't know where oysters were. And so as we've continued, we now see projects like the one I'm standing next to there that has thousands of oysters per square meter. And that's so much filtering power when you think about one oyster filtering about 40 to 50 gallons of water in a day. That's the equivalent of us drinking a cement truck and then filtering out that water. So through this, we've kind of decided and helped Brevard County come up with a habitat suitability index, which helps us to determine where we're spending taxpayer dollars and where we're doing this restoration work. So that's our fun oyster evolutionary process from the last few years. I'm going to go into other bivalves, clams. So what time? How am I doing? Doing good? Perfect. And so clam monitoring. Many of you that have been here probably in the 70s, 80s remember clams. Remember clams being pretty good here. Clams, unlike oysters actually like a freshwater rinse. That's why they like being in the mouths of tributaries or where the rivers meet our estuary. So Crane Creek area, Ballard Park area, good oyster areas. Clams, a little bit more selective. They don't like low salinity. And unfortunately, in the past few years, we've had some lower salinity numbers. And so we had to do a pilot project to figure out where clams currently belong in the Indian River Lagoon. Because we've had all this influx of stormwater. It's not just the pollution that comes in, it does lower salinity during those stormwater moments. And certain animals are more susceptible to die off during those moments and to stress. So let's talk about IRL clams. So Mercenaria, northern quahog, hard clams. And so same thing that you'd go and dig up in New Jersey are what are here. We also have Mercenaria campachensis, which is the southern quahog, and they overlap here and they actually can interbreed. But for the most part, in this area, we've seen hard northern quahog, but it is hard to tell the difference between the two unless you open up the shell, which then kills them. So for the most part, they're pretty much mutts here. But they are suspension feeders, and they prefer a salinity between 20 to 35 ppt. And so they spawn in the summer months, and then they have growth period between October and April. And so that is different than in the north. So their October to April time period in the north is actually their period where they shut down and just kind of try and survive because the water gets so cold. But here, the water temperature actually becomes their ideal water temperature to grow and to feed and succeed. And so with this 2021 clam pilot overview, we had money from St. John's River Water Management District, and we partnered with UF Whitney Lab, and we had 8 million clams spread throughout 100 different sites in the Indian River Lagoon. And we had a volunteer force that we trained and recruited. And then seagrass was planted at 10 of those 100 sites as well, just to see how they did together. And then monitoring of those sites was performed by Restore Our Shores. This is the project I was hired for. And it was a lot of fun. There was about 100 site number haunted me in my dreams. Made me lose a little bit of sleep. That's gone weird. Okay, but so when we did site selection, that's supposed to be there, but it's fine. When we did site selection, salinity minimum that we wanted to see at a site was 15 ppt, because what they prefer is that 20 to higher range. And so salinity minimum at a site that we would prefer was 15. Sediment type, we wanted coarse sand with low organic matter. Potential obstacles. So potential obstacles is we're having volunteers care for these 100 sites until we go monitor them. We don't want there to be any sort of potential obstacles like a down sailboat, things like that in the water where we have volunteers walking around looking after a clam bed. Water depth. Also, we have volunteers walking around looking after a clam bed, and they need to be able to reach down and care for it. So we had a water depth criteria. And so let's talk a little bit about the survival of this program. So biggest thing was these clams were actually spread out into a 10 by 15 area, and a protection net was put over them to help with predation. Because funnily enough, everything with a mouth, including us, likes to eat clams in the river. So stingrays, redfish, things like that. If the net came up, they got eaten. And we have that here. So we actually would record every time the net came off at sites. And sites where the net never came off, the survival was much higher. Because as the net came off, things came, and we would find fun little clam shards where the predators would come, crush them up, eat them, and run away. And so clams in this area really need some sort of cover net or protection, especially when they're small, because a clam's biggest defense is actually when it gets big enough to not just be crunched anymore. And that is their biggest defense mechanism. When they're small, they really can just get swallowed whole and crunched up. And so we look at this fun median. So means are fun, but a median is sometimes a better determination of what your entire population is doing. And so the median number for survival where the net came off was a 5% survival versus a 45% survival where the net stayed on for this entire project in even marginal areas where we put these 100 sites. Because we put these 100 sites in quite a few areas, even areas that were borderline, but it's a pilot project. We're testing everywhere. We want to see where clams belong. Find clam shards. A lot of fun to monitor. And so, predation was a limiting factor. There was a high mortality in the Banana River and North Basins. We saw sorry, I like how I click it now and it works. And so we had a high mortality in Banana River, North Basins, low salinity. There's low salinity, Banana River particularly, and Northern Indian River Lagoon. They have what we call a high water retention time. So the amount of time that it takes for the water to flow from the top of Banana River to the Indian River Lagoon where it meets at Dragon Point is almost 300 days. That's a really, really long time. And so not a lot of flow, and the North Basin is very similar. And so we saw high survival and growth in Central. And so this is the Central Indian River Lagoon location. This is the time and the size of the average size of the clams at these sites. So we saw a very steady growth. And so these clams started about the size of a dime, very cute, and ended at the size of a tennis ball, which was ideal in a lot of these central sites. In the sites where it was more marginal, where the lower salinity, we did not see them grow that big. They did not thrive necessarily as they did in the Central Basin. And so here we have some fun numbers. So percentage survival, 0.55% in Banana River. Not ideal. Average salinity was 24. So not super high, but not terrible, but that is an average. So we'd have some summer days where it's been 2 weeks since it's rained. Salinity is 30, but then it would rain and salinity would drop down in spring to 14 to 13 ppt. Not good for clams. And then Central Indian River Lagoon, average salinity 32.43, and then percent survival almost 45%. Really good. Mosquito Lagoon, where they actively still grow clams. That was our control. We wanted to have some sites up in Mosquito Lagoon to make sure, if they all died, maybe it was the clams. Who knows? You're getting 100 sites. You want to make sure that you have an area where you think and almost know that they will do well enough to have a good survival. And so Mosquito Lagoon, our control, did do well. Average salinity of 30%, survival 57.59. Mosquito Lagoon is also known for having high salinity consistently. And then Northern Indian River Lagoon, not a terrible survival rate at 13.88. Not good, but not terrible. Also lowest salinity. So that was our biggest trend that we did see, as well as predation. So really high predation rates, and also low salinity was not suitable for the clams. And so from this pilot project, Brevard County, like with our oyster gardening program, was like, why don't you guys try clam gardening? At some of these sites that did well in your pilot project, why don't we provide you some funding? So that funding for that pilot project was with St. John's River Water Management District for a water quality grant. This is now Brevard County Sorrel. And so we decided to take some of those sites that did really well and start gardening some clams. So we took 20 sites and we would put small clams. So we decided to buy them a little smaller because the bigger they are, the more money they can cost, which makes sense because it costs money to rear them. The bigger they get, the heavier they are. And so we got some smaller seed and we decided to use some clam bags because with the top netting procedure, you really dig up a lot of sediment through that monitoring. And we wanted for these, the purpose of this project was actually to be able to take them from homeowners and to maybe go put them on a site that has been vetted and maybe has seagrass. So we've noticed seagrass can act like a natural net to protect from predation. And so the purpose of this was to be able to pick them up from some of these sites and to be able to distribute them elsewhere. So we didn't want to rip up these people's bottom with clam scoops and stuff to get all those clams up. We wanted to be able to have them in bags like clam farmers do here in the in Sebastian and southern Brevard County. And so with that, so we got 1 million seed clams at 20% previously successful clam sites. Altered the methodology to address some lessons and to ease outplanting. So we wanted a little bit more protection from predation. So bag change. And goal was engaging the community to grow clams from smaller seed and plant them in appropriate areas in Brevard County. So overall, pretty good. Till we had some events in 2023. I don't know if anyone was here in 2023, but there were some water quality moments in this region specifically that were questionable. But we did engage quite a few people with this program, volunteer hours, quite a few. But clams planted at the end, not good. Only like 1,500. So at the end, we had some really unfortunate moments in 2023 where we had some low salinity in Central and low dissolved oxygen. And we know this specifically because of our lovely sensor monitoring program where we monitor water quality in this basin. And so at one of our sites, we actually could track where and when the clams most likely died and when and what. And so we track dissolved oxygen, temperature, water level, salinity, and we also have some light sensor sites that more or less is for seagrass. But light sensors can also track blooms. So algae blooms, when the water is super dense and no light is penetrating, light sensors can also track that. But this is 2023, our lovely 2023. And so this was the Sebastian algal bloom. And then you can see this is dissolved oxygen. So in this first red section for everyone on Zoom, Sebastian algal bloom, you see this red line. So the peaks are during the day. So peak algae bloom, when do we think that is? Sunny, mid-afternoon. Love it. Peak dissolved oxygen, blooming, doing well. And then you see how it plummets very sadly at night when the algae will start to die off at night because it's not receiving that sunlight anymore. And so you see it go up and down until we hit this first Sebastian fish kill, this first blue section. And you see how it stops peaking and starts to just that red line slowly just goes along the bottom. That is a fish kill. So that is how you track a fish kill. And that happened right next to quite a few of our clam sites. And it devastated them. It was very sad. A lot of them died. No oxygen, nothing living. Surprise, surprise. And then also Malabar fish kill, tracked that. You can see there's slight peaks in dissolved oxygen in Malabar, but we had essentially a few days there, a good 48 hours, where it was very, very low. And it doesn't take much, because if you notice, these also correspond in July. Bivalves particularly, and most invertebrates, their metabolism is linked to temperature. The warmer the temperature, the more they need to breathe, the more they need to eat. And so high temperature water here, so we're talking almost 30 degrees Celsius water, so almost 90, and low dissolved oxygen for long periods of time. And it killed them. Really did. And so unfortunately, we try to evolve every year. So we go 2024 clam gardening materials test. So we decided we were using a really small mesh that first year. Let's try a slightly bigger mesh with slightly bigger clams. Just get a little bit bigger. And so we also tested some different materials. So we went from the 2.4 millimeter bags, which was used in the 2023. We also tested 4 millimeter bags. And then we also tested a 4 millimeter cover net. In this, the 4 millimeter bag mesh performed pretty much the same as the 2.5 millimeter, and then as almost the same as the 4 millimeter cover net. And so we saw, then let's just highlight the bigger clams. Next page. 2024 results. So this is preliminary. We actually only outplanted these in December, but this is our fun clam haul from one day. So the average size was 25 millimeters, which is about that big. And then we raised 250,000. So from that number in 2023 to 250,000, significantly better, much better. And so this year, we did not see those obstacles that we saw in the 2023 year. 2024 had a relatively seamless year, not a lot of algae blooms, not any fish kills, much better clam return rate. We also did try another North Lagoon site just to try and see, okay, well, should we try again up there in Titusville area? Did not do as well. Again, we still had some live clams, but around the same survival rate as before. So what can you do? So this is the wrap up of my talk. So that's the evolution from Restore Our Shores for oyster reef and gardening and all the things that go into oyster restoration, and then clam restoration for Restore Our Shores here. And so this is just a page on what can you do to help other than coming to talks like this and staying educated in your community and supporting local restoration. And obeying the fertilizer ban, making sure that you're not seeing grass clippings and things going down the drain. Good conservation practices, so designing docks through mangroves without cutting them all down, because it is illegal. It is illegal. Stuff like that. So it's the fertilizer ban. I just want to say thank you guys for listening. And if you have any questions, let's get going on those.
If you have questions, please write them down and then raise your hand so I know to come and grab them from you. Laura, do you mind turning the light on really quick? Thank you so much. Okay, first I'm gonna give you a question from Zoom.
Sounds great.
Can the northern clams and the southern clams, when they interbreed, can their offspring still reproduce?
Yes, but there are studies by Bill Arnold, a PhD that was doing research in the early 2000s here about certain diseases that they can be more susceptible to. So shellfish have different reproductive diseases that impact them worldwide, and so those offspring can be more susceptible to those diseases and reproductive diseases in general.
Okay, questions in person, does anyone have anything?
I think I have the chart right. You were comparing the coquina bed and the steel mesh bed.
Mhm.
And there was a significant increase in both of them, but then they started to taper off.
So they taper off. So what happens is in the first year or so, the spike is all the spat go, and we see all this spat on our oyster reef monitoring because the shell is all blank. And as that goes on, you have adult oysters that are intermingling, and there's less space on that blank shell. And so you just kind of get a taper off on that high peak number because that's an increase. So like sea turtles, this is the best way I can put this is like sea turtles, oyster produce millions of larvae. Male, female oysters spawn, sex cells meet in the water column, millions of larvae. And those spat land on things. Not all those spat make it to adulthood. And so when you're going through and you're monitoring, you, depending on the time of year, you may see huge spikes in spat on shell. So a spat or a larvae on a shell would probably be under 10 millimeters. So itty bitty, but still visible to the naked eye. So in certain times of year, you see these peaks and then it tapers off and then you might see a peak again.
Okay, that's only temporary.
Yeah, it's kind of like, oh, we had a bunch of people move in and then some people didn't survive the move in. And only the strongest survive in nature. So does that make sense to everybody?
You mentioned that oysters are gregarious.
Gregarious, yes.
Is that why they have such big smiles?
Yes. Yeah, so oysters are gregarious. But do you mean like their shell opening, big smiles? Yeah. Maybe they're happy about their neighbors, but as someone who's run the oyster gardening program, sometimes they don't always like their neighbors because they crowd them out. And again, only the strongest survive. So if we have a spat shell that we get for the oyster gardening program, and Sandy knows, we will see them slowly grow and then push each other off, and some oysters will fall into the sediment and die. So sometimes they're happy about being near each other, sometimes not so much. Depends, strongest survive. It's the biggest theme in nature.
Does that become a genetic, like say genetic strain will push other genetic strains?
Essentially, yes, fastest growing wins.
All right. What does the fertilizer ban cover and how is it enforced?
So enforcement of the fertilizer ban is not necessarily, it's more enforced on like private companies that will fertilize lawns. They can get a ticket for fertilizing lawns during certain times of year. But privately, there's really not a system that would potentially get people in trouble for fertilizing their lawn in a time of year, which is why we try and tell people to not fertilize your yard in a time of year where you put it on there and it immediately rains and then it runs off of your yard. It's just a waste of money if you think about it in the long run, because if you're fertilizing your lawn at a time of year that's with like liquid fertilizer and it's going to rain immediately in the afternoon every day at 4, that fertilizer, only like a very small percentage of that fertilizer is actually going to be absorbed by the plant before it gets taken somewhere else and absorbed by other plants or algae in the lagoon.
What's a good alternative to chemical fertilizer?
I mean, for yards here in Florida, I mean, to be honest, I really think that yards here in Florida, if you don't plant St. Augustine grass, they don't need to be fertilized. If you plant an alternative grass species like Zostera, things like that, you really don't need a lot of care. They don't need to be fertilized every month. You will save money. So if you look at your yard and you're thinking about sodding it again or resodding it, consider a different species. St. Augustine grass, if you are also in a flood zone, is very low rooting. And so if you've ever seen it may lift up from the sediment in a flood area, Zostera and a lot of those other species are deep rooting. So that's also why they need less care, is they root deep, can preserve water underneath the ground, reach water underneath the ground, versus St. Augustine grass. Not great for that.
What is the current status of the 2009 oyster reefs?
The current status of this 2009 oyster reefs, some of them are doing well. Some of them aren't doing very well and have been mostly ripped up. And every time we go there, we do monitor all of the projects we've ever done, which is a lot, once a year. And when we go there and we see certain materials not doing as hot, we will take out some stuff. But we currently do not have, like, they're all still meeting the criteria for habitat. So they're not being actively pursued in any way other than there's habitat there. There may or may not be oysters there, but there's things living in it, leaving it alone.
Are septic tanks a factor in the pollution to the IRL that affects the oysters?
Yep. That's a question. So when I say that, I had a recent person that I have been working in their backyard since the clam project in 2021, lovely people in Grant, and they were rebuilding a house and redoing it, and they realized that their septic tank was open bottom. And I'm like, oh, I swim here. So yes, update your septic, especially if it's a certain number of years old. You don't know what was put in there. The regulatory statuses back then, not great. So make sure if you have to put in septic, do your homework, figure out what's going to be good for the lagoon, what's not going to leach unfortunate materials into your backyard. And if you are doing a fresh new build and you're in an area that's supposed to have sewer lines brought up, think about building in a way to connect your house to the sewer system while you're building, rather than later on having to figure out a way to disconnect your septic and route a way to actually get to sewer. That
That's
is
actually cheaper in the long run, isn't it?
Yeah, if you are building from scratch and you decide to put a hookup at the front of your property that is closed off but could eventually be connected to sewer, yeah, it'll be significantly cheaper in the long run, especially because they're already plumbing and digging up your whole yard anyway. So
Can you just abandon your septic, or do you
you
have
can actually close it and you can pay to have it drained.
to just abandon?
Yeah.
Hold up.
You don't have to pull it up. You just need to either fill it with something or have it drained. Again, I'm not the number one person. My friend Jessica works at the county, where they actually do the permitting for septic systems. She would be that. There is like a department at the county. They are a great resource. They will tell you whether or not the company that is installing your septic is doing it the right way, because God forbid they don't. There's been a lot of things that have happened there where people have not had permitted septic systems and they have had to rip them out after already paying contractors. So make sure your contractors are legit and good if you are putting in a septic system, and that you're getting the right kind of septic system for the long run. Any other questions?
In terms of, so the causeways obstruct the flow of the water.
Yep.
So does that mean it's more important to put bivalves in areas where, like the causeways, where the water flow is obstructed, or does the water flow being obstructed mean they can't survive there?
So it just means that there's restricted flow for larvae to get there. So a good example would actually be, we have a beautiful project that is in the, for lack of a better term, the armpit of the O'Galley Causeway on the southern side. Beautiful project, tons of oysters. Just on the other side, beautiful projects, still have a bunch of oysters, less. So what happens is the oyster larvae that is mostly, for what we know, from the southern lagoon in our natural oyster reefs that we still have, Turkey Creek, Sebastian River, where there are still natural oyster reefs that are producing lots of oysters. Oyster larvae, when they flow north, the first barrier they hit, 192, second, O'Galley. There's still flow underneath that causeway. There's just a land obstacle that narrows it, kind of like a funnel. So you're going to get a lot of stuff that hits the side of the funnel, but doesn't necessarily go past it. And then as you get further and further north, it is a factor. Does that make sense?
Any other question cards?
I don't have a card.
Okay, it's okay, just speak up so that the speaker can hear you on Zoom.
Okay, in the more recent oyster projects, you described using coquina.
Coquina.
Where do you get the coquina from?
It is naturally it's naturally from quarries in Florida.
It's all over the place. People that are building a new house, dig it out, there's big rock piles on rock drive.
Yeah, Rockledge is named Rockledge very aptly. It is sitting on a bunch of coquina from prehistoric times. So coquina is all made from a species of worm that is now dead and long gone. But we are essentially in an area where there was just a giant reef, kind of like coral, but it was made from these prehistoric worms. And it's nice because it keeps Florida slightly above sea level.
How much room for growth is there in this program?
Tons. So we actually we have permission, we purchased a barge, and that is now how we do our projects. So we have a barge where we fill bags, what are they called? Kind of construction like bags, stuff that they would fill sand with. And we fill it with oyster shell, put it on the barge. There's a crane on the barge. We build the outline and we use that crane to dump the oyster shell in. So that is we're now building projects that are in the next probably year, 1/4 of an acre large. So a lot of room for expansion.
Are you participating in any groups in Indian River County? I live right across from the Sebastian.
So Brevard County funding, because we use Brevard County's funding, we are limited. We did do projects in the Indian River County for our pilot project for clams, and so they are aware of those of that data in Indian River County area for clams. But because Brevard County soil tax is what funds the oyster reef right now, we currently aren't doing projects in Indian River County.
Can I be trained?
I know for a fact that Indian River County is looking at doing projects like this. It's just at a smaller scale right now. But they have, I believe, done oyster reef projects in the areas of like Pelican Island.
Is this through the county?
Through the county. Through Indian River County. So their natural resource department.
So there's a lot of blacktop driveways up and down Rockledge Drive.
Yeah.
And every once in a while, somebody comes along and makes them real black. What is that stuff?
Tar.
Is it oil?
Yeah. Tar.
Is that health food for the oysters?
No. No, it's not. But I don't know what you tell people that have had houses there for years and years, is they're just essentially updating what is already there. New projects do have requirements for certain amounts of the property having permeable surface. And so if you ever hear about permeable pavers and people having to use those because of the amount of pavers they want to put on their driveway or on their property, those are permeable, so the rainwater can go through them, and they are pricey. But if somebody's building something new, then that's what they'll do. Or if they have the money and they want to update their driveway and you want to let them know. But I think the biggest thing isn't just necessarily re-tarmacking stuff. It's probably when people rip up a driveway and decide just to throw it over the lagoon wall with all the concrete chemicals and stuff that are actually in it, because it can change the pH of the water surrounding it, and eventually it'll all leach out. You know, the 70s, the whole motto was solution to pollution is dilution. It's not that anymore. It does affect everything eventually. And it will affect that area for a long period of time. But I do think that a lot of people just kind of rip stuff up from their house and drive away and decide, okay, well, I'm gonna shore up my shoreline, throw it over the edge, and that's just not what you should do with that material, because you don't know what chemicals were used in it. And you also don't know if there's rebar or anything in there, because that's what I don't want to do. I don't want to be walking around the lagoon, step on rebar. That would be really not a good day.
A note for the previous question about Indian River County. The county is partnered with Florida Institute of Technology right down the road for their Living Docks oyster mat program, and they are looking for homeowners with docks ideally. So if you want the link or if you want a connection, I can give you the contact.
Yes.
Person.
And
Awesome.
the Living Dock project is very different to what we do.
I have a job.
Yeah, so what they'll do is they'll wrap your dock pilings in oyster shell to provide more surface area for oysters to land. Which doesn't require the amount of permitting that ours do. Ours are a 2-agency kind of a thing.
Are any of these oysters or clams harvested for food?
Oh, yeah.
I mean, are they sold to restaurants or?
So, oh, not now. They were harvested for food ages ago.
Oh, yes.
This area is not currently now in any sort of zone by FWC that allows for harvesting.
So they just populate and populate.
The goal is for them to continue to populate. We currently don't have the best water quality in this area.
Yeah.
And most shellfish are ranked on water quality, and that's how you can determine price and how much you can charge per oyster. Wouldn't eat them from here.
I thought there was an oyster farmer in Sebastian.
There is an oyster farmer in Sebastian. They're right near the inlet. They get a nice freshwater, not freshwater, but like fresh saltwater wash, where they get some, you know, pull from that tide and get some ocean water in there, which is a higher water quality than the lagoon.
And it's loaded.
She's I know her. She's great. There's also quite a few clam farmers. They've had quite a few hits the last few years. We've almost lost our clamming industry overall here in Brevard County. There's still some left. Indian River and anything south of the inlet, because they are the Sebastian Inlet, they are influenced by multiple inlets. Salinity is significantly higher down there, and their tidal range is higher as well. Over here, it's about 1 inch. In Sebastian and that area, it can be almost 6-7 inches. Especially during king tide season. Other questions?
Would mussels work as well as clams or oysters?
So the mussel species we have here are not the mussels we necessarily eat, and they don't get very big. They're and their habitat is somewhat limited now. Does that make sense? Most of the mussels we run into are Atlantic paper mussels, which are can be very delicate, and they can grow in large abundances, but we don't see them very much anymore in those large abundances, which they do filter, but again, they are at most the size of like the end of your thumb, my thumb, which is tiny, maybe not the end of your thumb. And then we also have freshwater mussels that we see in canal systems. Just because the canal systems here in Brevard County can accumulate large amounts of fresh water just because there's not a lot of flow, which is why they build up a lot of muck. And so the freshwater mussels we'll see in there. And I don't, again, not really the Indian River Lagoon portion, but I think there's freshwater mussels in some of the lakes. And quite a few mussel species, specifically in Texas, from what I understand, are being used for freshwater rejuvenation, but not a lot here in Florida.
If we have any more questions, what's your email address?
I can put that up there. I don't always give it out. I'm pretty good about my email. That is the best way to contact me. Phone, my office phone. No. you want me to write it down, then you can put it up on the screen? Like you can post it in the Zoom chat and then I will.
But yeah, but it is about 1:05, just so everybody knows, if you have to get back to work. I will put it, so everyone who registered will get a link to the YouTube video, and I'll put Hope's email in the link as well. Yeah. So thank you all so much for coming today. Have a great rest of your day.
Yeah, thank you guys so much again. Thanks. If you guys have any questions at all, also the Restore Our Shores website, restoreourshores.org, has all of this information pretty much that I put on there. It also has the clam project final report that actually got published for the St. John's River Water Management Project. So if you really are interested in those numbers too, go out there. And then we also have quite a few resources for oyster stuff too.
Thank you very much.
Updates on this, yeah.